Yes. Now we have another method to show the function is invertible and find the inverse. Let f be a function from n to r is defined by fx is equal to 16x square plus 8x plus 9. Then show that f from n to range of f is invertible and find the inverse of f. Now we have solution. Here fx is equal to 16x square plus 8x plus 9. We have to consider y be the arbitrary element of range of f. Therefore fx is equal to y. This implies y is equal to fx 16x square plus 8x plus 9. And now we can write this as 16x square plus 8x plus 1 plus 8. It becomes 4x plus 1 whole square plus 8. It means y minus 8, its root is equal to 4x plus 1. Is it clear? Here x is belongs to n, capital N, natural number, set of natural number. Therefore 4x plus 1 is positive. This term is also positive. And this implies x is equal to square root of y minus 8 minus 1 divided by 4. X is equal to square root of y minus 8 minus 1 divided by 4. Is it clear? Now we have to define a function. Either consider a function g from y to capital Y to n, where this capital Y is the range of f. Capital Y is the range of f such that gy is equal to square root of y minus 8 minus 1 divided by 4. Is it clear? Now we have to define this. And now we have to do with second definition of invertible function by f of g and g of f. Now we have to consider g of f. G of fx. G of fx, let x belongs to the set of natural number, that is the domain of the function f. Now g of fx is equal to g fx. G fx. What is fx? Fx is 16x square plus 8x plus 9, and therefore g of fx becomes g of 16x square plus 8x plus 9. Substitute this value in place of y in g, and therefore it becomes square root of 16x square plus 8x plus 9 minus 8 minus 1 divided by 4. And therefore it becomes square root of 16x square plus 8x plus 1 minus 1 divided by 4. And that is the whole square of 4x plus 1. It becomes 4x plus 1 whole square minus 1 divided by 4. This square will be cancelled. You will get 4x plus 1 minus 1 by 4. that is equal to x. What is x? X is the set of natural number, and therefore that is equal to in. Is it clear? Now we have to define f of gx. F of gx, and now here gx, let x belongs to capital Y. Capital Y, that is the domain of function g. F of gx means that is equal to fgx. What is fgx? Here gy. In space of y we have to substitute x. It becomes f of square root of x minus 8 minus 1 divided by 4. Is it clear? And now substitute this value in fx. Fx is 16x square plus 8x plus 9. Substitute here. It becomes square root of x minus 8 minus 1 by 4 whole square, 16 into this, plus 8 into square root of x minus 8 minus 1 by 4 plus 9. Simplify this 16, because whole square is there, 16 will be cancelled. Whole square of this, it becomes x minus 8 plus 1 minus 2 root of x minus 8 by open the identity of whole square. And now here this 4 and 8 will be cancelled. You will get 2 root of x minus 8 minus 2 plus 9. And now this term will be again cancelled. Here you will get 9 minus 2 plus 7 minus 8 plus 1 minus 7 and x. This will be cancelled. You will get x, that is equal to iy, because here x belongs to capital Y. It means f of g is the identity function, and f of g is the identity function, g of f is the identity function. It means f of g is equal to iy and g of f is equal to in. It means f is invertible and the inverse of f is the function of g. It means f inverse y is equal to square root of y minus 8 minus 1 by 4. Is it clear? Any doubt?